Hey guys, today we'll be doing May-June 2024 paper 2, variant 3. So let's start it. Question number 1. Sodium chloride is a liquid at 900 degrees Celsius. Which row describes the arrangement and the motion of particles in sodium chloride at 900 degrees? So, sodium chloride is a liquid at 900 degrees Celsius. So, if they're asking at 900, it means at 900 degrees Celsius, it's a liquid. So, we'll see that how the particles are arranged. They're not regular. In liquid, the particles are arranged randomly. And about the motion of the particles, they don't vibrate. At their position, their movement is also random. They move randomly, but still they are touching each other. They have a loose arrangement in liquid. Now, question number 2, hydrogen chloride gas HCl reacts with ammonia gas to form solid ammonium chloride. So, hydrogen chloride gas reacts with ammonia to form ammonium chloride, whose formula is NH4Cl, and it's a white solid. The apparatus is set up as shown. After a few minutes, a white cloud of solid ammonium chloride forms where the two gases meet. So, hydrogen chloride particles are diffusing and ammonia particles are also diffusing, and they both meet at this point, which is near to HCl. This point is near to HCl. The experiment is repeated using hydrogen bromide gas HBr in the place of hydrogen chloride. So instead of this hydrogen chloride, now they have placed hydrogen bromide. How far along the tube does the white cloud of solid ammonium bromide form? Now, the ammonium bromide NH4Br, they are saying that where will this ammonium bromide cloud will form? Let's see. For the diffusion, for the movement of particles, we have to see whether the particles are heavier or lighter in weight. If we see for hydrogen chloride and ammonia, the molecular mass of these two compounds, hydrogen chloride, hydrogen is 1 and chlorine is 35.5. So the molecular mass of HCl will be 36.5. And for ammonia, it's 17 because nitrogen is 14 and hydrogen is 1 multiplied by 3, so total 17. So ammonia particles are lighter in weight, so they will move lighter. So they will move, means they are lighter, so they will move faster. They will move fast, and hydrogen chloride particles move slow as they're heavier, so they both meet over here. Now, if we talk about HBr, hydrogen is 1, and the bromine atomic number is almost 80, which makes hydrogen bromide as 81. So as you can see, that hydrogen bromide is almost double than HCl. So it will move more, it will move slower than hydrogen chloride gas. So if it moves slower than hydrogen chloride gas and the same ammonia particles will move really fast, then the possibility is they both meet at point A. Because it's much more slower as compared to hydrogen chloride. So if with hydrogen chloride, the cloud is forming over here at point B, then with hydrogen bromide particles are more slower. So the cloud will form at A. Next, question number 3. Substances P and Q both conduct electricity. P is a mixture of two different type of atom. Q is made of only one type of atom. It means it's pure. It's made up of only one type of atom. Which row describes P and Q? Now, P is a mixture of two different type of atoms. If it is a mixture, then it should be alloy because compound is not a mixture. Compound is a chemical change. Then Q is made up of one type of element. So element, compound, alloy, element. Yes, here it's an element because it's made up of only one type of atoms, means it's pure, it's a pure element. So the answer is A. Number 4, an atom of element R contains 15 protons, 16 neutrons, and 15 electrons. So this is the whole composition of element R. What is R? So the element R has 15 protons. It means its atomic number is 15. And we identify an element based on its atomic number. The identification of the element is its atomic number. So atomic number 15 is of phosphorus. So phosphorus is the answer. Number 5. Which molecule contains a double covalent bond between two atoms of the same element? Same element means there will be the two atoms of the same element, two atoms of the same element, and they will be having double covalent bond between them. So let's see. For carbon dioxide, CO2, the structure is that carbon has a valency of 4 and oxygen, two oxygen atoms have the valency of 2. So they will share 2 electrons with each other. So there will be double bond between carbon and oxygen. For ethanol, ethanol structure is CH3, CH2, OH. This is ethanol. C2H5OH. So as you can see, there is no double bond in ethanol molecule. Then for ethene, ethene is C2H4. So for ethene molecule, C double bond C, because it's ene, it's from the alkene family. So it means there will be carbon-carbon double bond, and then there are 2 hydrogen atoms. So this indicates that ethene has carbon-carbon double bond, and this is our answer. Ethene. And as for the nitrogen, we can check. Nitrogen has a valency of 3. So it forms 3 bonds with nitrogen. N2. It has triple bond between nitrogen. They are saying that we want double bond. So that's ethene with carbon-carbon double bond. Question number 6. Silicon oxide is a covalently bonded molecule. Which statements are correct? Now, it's a covalently bonded compound and also it's a giant structure. Silicon oxide is a giant structure. Which statements are correct? Silicon atoms form 4 single bonds in silicon oxide. Silicon is present in group number 4. If it is present in group number 4, that means it has 4 valence electrons. 4 valence electrons means it needs 4 more electrons to get completed. So silicon has the valency of 4, so it forms 4 bonds in silicon oxide. So that's true. Number 2 statement, oxygen atoms form 2 double bonds in silicon oxide. No, oxygen does not form double bond because silicon oxide, over here, silicon is combined with 4 oxygen atoms like this in the formula. Silicon oxide has the high melting point. That's correct because as I said that silicon oxide is a giant structure just like diamond, its melting point is also very high. Silicon oxide contains 1 silicon atom and 4 oxygen atoms. Silicon oxide contains 1 oxygen atom and 1 silicon atom and 4 oxygen atoms. This might be true, but silicon oxide is a giant structure. So it not only contains 1 silicon and 4 hydrogen atoms, but the structure keeps on continuing and growing. So this oxygen is combined, or each oxygen is combined with more silicon, and each silicon is again further combined with 4 oxygens. And the structure continues, making it a giant structure. And also, if we see the formula of silicon oxide, then the formula is SiO2, which makes silicon 1 and oxygen 2 atoms. So a compound is made up of 1 silicon and 2 oxygen atoms. So that is why statement 4 is wrong. So the answer is 1 and 3. Question number 7. The equation for the reaction of iron 3 oxide and carbon monoxide is shown. Now, if you remember, this is the equation of a blast furnace in which we extract iron from its ore hematite. We have this equation, what is the percentage yield of iron when 16.8 grams of carbon monoxide reacts completely with iron oxide to form 8.96 grams of iron. Okay, so they're asking for the percentage yield. What's the percentage yield? The formula of the percentage yield is actual yield divided by predicted yield multiplied by 100. This is the formula of the percentage yield. So we need to find the actual yield and predicted yield. Both of the yields are of the same substance, which is the product. Over here, they are asking us that what is the percentage yield of iron, means this product iron which is forming. They're asking you about this. Now, when percentage yield of iron when 16.8 grams of carbon monoxide, they have given us the grams of carbon monoxide is 16.8 grams. So starting from this, we will find out the iron predicted yield. It reacts completely with iron oxide to form 8.96 grams of iron. So one of the yield of iron is already given to you in the question. This 8.96 gram of iron is its actual yield. This is the actual yield of iron which is given. The given mass is always actual yield. And we need to find the predicted yield by using the mass of carbon monoxide. Let's take the ratio between them. Carbon monoxide ratio iron. So first we'll see from the equation that 3 moles of carbon monoxide contains how much grams? So it's 3CO. Carbon monoxide is 2 plus 16, which makes it 28. Now we'll do 28 multiplied by 3. So 28 multiplied by 3 is 84. So for carbon dioxide, we are getting 84 grams and 2 moles of iron. Okay, the atomic mass of iron, we will multiply the atomic mass of iron with 2. What's the atomic mass of iron? It's 55.5, almost 58. 56, sorry. So we will multiply this 56 with 2, making it 112. So the iron mass is 112. So the first ratio we'll see from the equation, that what is the mass of 3 moles of carbon monoxide and what is the mass of 2 moles of iron in the equation. We just calculated the mass of carbon monoxide and iron from the equation. Now, if 84 grams of carbon monoxide are giving 112 grams of iron, then 16.8 grams of carbon monoxide will give how much iron? In the question, they're asking about 16.8 grams. So we'll do the crossover and find out the answer of iron. We will do 16.8 multiplied by 112 divided by 84. It will give us the mass of iron. 16.8 multiplied by 112 divided by 84, which gives us 22.4 grams. So this is the predicted yield of iron. Predicted yield of iron. Now, we will substitute the two yields, the actual yield which is given in the question and the predicted yield which we just taken out, will add it in the formula of the percentage yield. So it is actual yield, which is 8.96 divided by the predicted yield 22 14.4 multiplied by 100, it will give us the answer. 8.96 divided by 22.4 multiplied by 100, and the answer comes out to be 40. Next question. What is the volume of 14.5 grams of gaseous butane at room temperature and pressure? Now they're asking us about the volume of gaseous butane. The formula for the volume is moles is equal to volume over molar volume. This is the formula we use for any gaseous substance if the volume is asked. Volume over molar volume. Now over here, volume we have to find, and molar volume at room temperature and pressure, molar volume has a fixed value which is 24 decimeter cube. So molar volume is 24. The volume is required. We don't know the moles, so let's take out the number of moles first. We have been given the mass here. So we'll find out the number of moles by using the formula moles is equal to mass over molar mass. Here, the mass is given to us, which is 14.5, and the molar mass, we have to calculate the molar mass of butane. Butane is C4H10. So let's calculate 60 for 12 is for carbon. 12 is the atomic number of carbon multiplied by 4 atoms, plus 1 is for hydrogen multiplied by 10. And we'll calculate it. 12 into 4 is 48, plus 1 into 10 is 10. So 48 plus 10 gives 58. So 58 is the molecular mass. So let's divide 14.4 divide by 58. It gives us the number of moles, which are 0.25. Let's substitute these number of moles in the previous equation. So the number of moles now are 0.25. We need to find out the volume divided by the molar volume has a fixed value, which is 24. Let's take it on the other side of the equation. This 24 will multiply with 0.25 and take out the answer. 0.25 multiplied by 24, and the answer is 6. 6 decimeter cube. So this is our answer. Next question is of electrolysis. Aqueous copper sulfate is electrolyzed using copper electrodes. This statement describes what happens during the electrolysis. Now we're doing this electrolysis of copper sulfate which is blue in color, and we're doing this electrolysis using copper electrodes which are reactive. The copper electrodes are reactive electrodes. So what happens when we pass the electricity? Because the copper atoms are reactive, so they lose their electrons. The copper at the anode start losing its electrons. So what do we get at anode? We get the copper atoms become copper ions after losing 2 electrons. So they lose 2 electrons, and these electrons start traveling out of the anode. They go from the external circuit into the cathode. So they move from anode towards cathode, towards this copper cathode. So these are the electrons. Now, because of copper 2 plus, this anode becomes positively charged. And then these copper 2 plus ions, they get attracted towards the negative cathode. So the copper ions travel from anode to cathode from the electrolyte. And on the cathode, these copper ions again gain 2 electrons to become copper metal, and then they start depositing on it. The copper will start depositing on the cathode, and the anode will start to decrease in size. It will start to decrease in size because the copper ions are moving from here. Now, this is the whole explanation. Let's see which option is correct. Copper atoms gain electrons at the cathode and copper 2+ ions lose electrons at the anode. Copper atoms gain electrons? Yes, there is a gain of electron at cathode, as I told you, cathode, they gain the electrons, but not the copper atoms. Copper ions gain the electrons. Copper ions are copper 2+ and they gain electron. They gain 2 electrons and become copper at cathode. And here at the anode, the loss of electrons does happen, but not with the copper ions. The copper atom or the copper metal, it loses its 2 electrons at the anode. So this statement is wrong. Next, electrons move in the external circuit from the positive electrode to the negative electrode. Now this one is correct. Because as I told you that when we pass the electricity, when we give voltage to it, the copper present at the anode loses its electrons and the electrons then start moving from anode, traveling to the whole external circuit and they end up at cathode. So from positive electrode, they move towards the negative electrode through the external circuit. So B option is correct. And if we see the other options, then copper 2+ ions move through the electrolyte from cathode to anode. No, because copper ions move from anode to cathode, as I explained above. Also, the copper is formed at the cathode and oxygen is formed at the anode. Yes, copper does form at the cathode, but at anode, oxygen is not formed. Anode forms copper ions which leave the anode and the anode starts decreasing in size. So option B is correct. Question number 10. Electrolysis is carried out on concentrated aqueous potassium bromide using inert electrodes. What products are formed at the anode and cathode? Now, keeping in mind that anode is positively charged and cathode is negatively charged, the concentrated aqueous potassium bromide, let's write the ions. From potassium iodide, from potassium bromide, we get K positive and Br negative. These are the 2 ions we get from potassium bromide. Now, as it is an aqueous solution, so we get water ions as well, H positive and OH negative. Out of these 2 positive ions, which will go to the cathode, because cathode is negative. So these 2 ions will run towards the cathode, but only one will discharge. Which one discharge? We have to see the reactivity. That element, the ion, which is less reactive, will go to the cathode. So from potassium and hydrogen, if we see the reactivity series, then hydrogen is less reactive. So it will go to the cathode and form hydrogen gas. So at cathode, hydrogen gas is formed. There is one option, the only one option with cathode hydrogen, which is bromine. Let's see, it is a concentrated solution. Concentrated solution means there will be more salt, there will be more solute, more potassium bromide. So if there will be more potassium bromide, then bromide ions will discharge at anode. If it would be dilute solution, then the water ions, then hydroxide ions from the water, they will go to anode if it is dilute. But as it's a concentrated solution, so there will be more solute and bromide ions will go to the anode forming bromine gas. So option A is correct. We'll do the rest of the questions in my next video.